So yesterday we are discussing this IP headers, right? So now we are going to see IPv6. We are going to see which topic? IPv6.
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 So why we go for IPv6 means IPv6 includes lot of addresses. You can't imagine how many number of addresses are there. If you are accessing internet, you need an IP address, right? Without IP address, can't we access internet?
No.
No, right?
No.
The total number of IPv4 address in the IPv4 block is 4.4 billion. Is our world population is 4.4 billion users?
No.
No,
Yes.
right?
Yes.
Is it world population is 4.4 billion? In India itself, we are having some 2 billion or 1 billion, I think.
Yes.
So how comes then the rest of the world is 4 billions? Okay, so we are running out of the shortage of IP addresses. Okay, so
Yes.
if any user want to access the internet, they need what? An IP. As the IPv4 address blocks are getting exhausted, they are bringing up with the new IP addresses. What is that? IPv6. Why not IPv5? They also invented IPv5. They have some drawbacks. They overcome the drawbacks. It was 64-bit. Then they enhanced the IPv5 with further 64. So totally IPv6 is how many bits?
128 bits.
Very good, 128 bits. Okay, so you have 2 power 128 addresses in IPv6. Similarly, in IPv4 you have 2 power 32 addresses. Clear?
Yeah. Santosh, your screen is not visible.
Okay. Yes. So IPv6 addresses how many bits? 128 bits. And also in IPv6 they don't have broadcast. IPv4 drawback is broadcast. Unnecessary broadcast in the network which consumes much bandwidth in your network, which will not allow you to provide bandwidth for packet processing. So in order to overcome the drawback, broadcast is replaced by which one? Multicast. There is no broadcast here. Broadcast is in IPv6 is replaced by which one? Multicast. You know multicast or not?
Yeah.
Yes.
Okay. So similar like your IPv4 header only, your IPv6 also. Okay. What are all the header fields in your IPv4? Yesterday I told, right? What are the fields comes inside your IPv4? One by one you are supposed to say. If you say this answer, then IPv6 makes easier for you. If you are not answering, then I will not tell you for IPv6. Tell me what are the fields inside your IPv4. Check the notes and tell me.
Version,
Very good. Version,
type of
I,
services,
type of services, okay. Header length and type of services.
packet,
Very good.
packet length,
Packet length, okay. Padding, very good.
flag,
identification,
flag, fragment, offset,
Okay, fragment offset, flags,
time to leave protocol, header
TTL
checksum.
TTL protocol field, header checksum,
Yeah.
then
Source
source
address,
address,
destination
destination
address,
address,
destination address, source address,
option,
then options and padding. Okay.
padding. Yeah.
Similarly, here also see version is there. Are you able to see my screen? Version is there, right?
Yes.
Their type of service we will say, right, in IPv4. Type of service. What is the purpose of type of service in IPv4? Here version is IPv6. Okay, version is IPv6. What is the purpose of type of service in IPv4?
Data type.
No, the data type is protocol field, man.
It is the media part where we can send the video or something like
Very good, very good. Related to quality of service, right? Video, voice, data, FIFO algorithm, all these things I told, right? Okay. So similarly in IPv6, which field is responsible for quality of service? Traffic class. Which field is responsible? Traffic class. Okay. And next field is flow label. Next field is flow label. This flow label will track your source and destination and will keep the same treatment for whatever the traffic which is giving before, how it was handled. This in the same way it will handle. It will track the path from source to the destination via which field? Flow label. Via which field? Flow label. So this field is also somewhat related to your traffic class only. Okay, but it is related to path. So in which direction it is traveling from source to your destination, that is your flow label. Payload length is your packet length. Payload length is your packet length. Whatever the packet length we are saying, right? Similarly here the packet length is replaced by which one? Payload length. Okay, you know the protocol field in IPv4, right? What is the purpose
Yes.
of protocol field in IPv4?
What protocol we are using, like TCP or something like that.
Yeah, ICMP, IGMP, EAGRP, OSPF, like that. So many protocols are there, right?
Yes.
That
Yes.
protocol field is replaced here as next header. So what is the field in IPv6 called as protocol field?
Next header.
Next header. And your TTL value is replaced as which one here?
Hop limit.
Hop
Hop
limit.
limit.
Very good. Hop limit. Rest and all same, source address and destination address. Okay. This is your header of your IPv6. IP version 6. This is also managed by your IANA. Who is IANA? Any idea? IANA? Internet Assigned Number Authority, I told you, right?
Yes.
Yes.
Who manage IP addresses. He is the owner of IPv4, IPv6 addresses. Okay, your IPv4 addresses is in dotted decimal format. In which format IPv6 is there? In which format?
In decimal form.
Very good,
Hexadecimal.
hexadecimal format. Okay, you know hexadecimal values?
Yes.
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 What is the binary value of F?
1111.
1111. What is the binary value of A?
1010.
1010. Okay. You see the explanation they have given for IPv6 header. Just go through this slide, then I will go for next slide.
Santosh, did you start the recording?
Yes, it is recording. See here.
Okay.
Suddenly you asked, I afraid, man. I shocked. I started already. So your IPv6 address is in which format? Hexadecimal format. How many bits meant for IPv6?
128.
128. Is there any broadcast in IPv6?
No.
No, it is replaced by
Multicast.
Multicast.
multicast. Okay. You know fragmentation?
Yes.
What is fragmentation?
Fragmentation means to broke the smaller parts and solve it separately. That means
Okay, that
fragmentation.
is dividing the packets into small packets. Okay.
Yeah,
Yes.
Yeah, why we are dividing? Why can't we send as it is?
For preventing data loss.
No.
No, the MTU size.
MTU cannot take.
Who told MTU size? Very good. So if your below layer is having the capacity of how much? MTU 1500, right? So if any higher layer data exceeds 1500 in layer 3, what process it will do? Fragmentation.
Fragmentation.
In IPv4 networks, every router will do fragmentations. That is a CPU triggering process. So in order to overcome the drawback, what they did in IPv6, only the source and destination guy will do fragmentation. Rest of the guys between the source and destination, they will not initiate which process? Fragmentation. Okay. So in order to reduce the load of CPU in network devices, this process is applied in IPv6, not in IPv4. Okay. And see the, yes, your IANA sets some rules for IPv6. This hexadecimal format address are separated by colons. Okay. So if you write this F in binary, 4 bits will come, right, guys? If you write E in binary, 4 bits will come.
Yes.
If you write 8 and 0, further 8 bits will come totally. So totally how many bits are there? 16,
128.
16, right? In IPv4 we have only
Yes.
8 bits, but in IPv6 we have how many bits? 16 bits.
16.
So this 16 bit is called as quartet or hexatet. Okay, in IPv4 we call them as octet. So totally in IPv4 address 4 octets will be there. First octet, second octet, third octet, fourth octet. But here 8 quartet will be there. Check it out. 1, 2, 3, 4, 5, 6, 7, 8. 8 into 16 is how much?
24.
24.
8 into 16.
Yeah, 16 into 8 is how much?
128.
128.
128. Okay, so that's
Yes.
why IPv6 is how many bits? 128
128.
8 bits. Okay, so this IANA is setting some rules for simplification of IPv6 address. For what purpose they are setting the rules? To reduce the address, not to write like all the 128 bits. We can simplify it and reduce the addresses. We can write it very in a simple way. So for that some rules are set. If you have zeros like this, you no need to write all the 4 zeros. You can write it as what? Single zero. Is that clear? Rule number 1. Rule number 1 is clear or not?
Yes.
Yes, Santosh.
And if you have some, you know that 16 bits are called as quartet. In all the quartets, continuously you are finding it zeros. Okay, no other values are coming. It doesn't matter how many quartets are zeros. Okay, so if you see that the continuous zeros in all the quartets or hexatets, you can replace it with double colon. It is not used more than once, it is used only once. This second rule is clear.
Yes.
Okay, now third rule, I written FE80. Okay, you can't neglect this 0 which is coming after any hexadecimal digits. If you neglect, it doesn't make any sense. You need to write that 0 as it is. That's why I written without 0 it is wrong, with 0 it is right. Okay, whatever the value, hexadecimal values After that hexadecimal values, if any zeros are followed, those zeros make significance in your IPv6 address. Don't neglect that zeros. Is the rule 3 is clear?
Yes, Santosh, but I have a doubt.
Hmm.
Is this case sensitive?
Sorry?
Means is this case sensitive? I think
No, it's
I
not. It's not case sensitive. You can write it in small letters also.
in the ASCII value changes, no? That's why I was asking.
ASCII values. Here we are considering hexadecimal values, not ASCII values.
Okay, but
Okay. I think you are reading too much. I think.
no. Much.
Yeah, you confused with the ASCII values, uppercase and lowercase characters, and you confused with the hexadecimal. So hexadecimal is different. ASCII value is different. ASCII values are applied in encoding and decoding process. Okay, whereas hexadecimals
Yes.
are applied in transmission of data. Clear?
Okay, got it.
Yes. Is the rule number 3 is clear?
Yes.
Rule number 4 is, if any hexadecimal values preceding any zeros, some zeros are there, after that hexadecimal values is followed. Okay, those zeros you can neglect. It doesn't make any significance. You can write that hexadecimal value alone. That is a numerical value apart from zeros. Okay, so rule number 4 is clear.
Yes.
If I so
Yes, sir.
all the 4 rules I applied in the above given IPv6 address. See, I reduced and I written the concise address of the given one. Is that simplification of IPv6 address is clear, guys?
Yes, yes.
One for development.
Sorry,
Lanza team is ready.
I said yes, Santosh. It's
someone is
okay.
talking. Did they turn on the mic?
No, I was talking. It's okay. We got that rules.
Okay. Yes. So next slide, the classification of IPv6 addresses. Classification of IPv6 addresses. So IPv6 address is classified as unicast, multicast and unicast. Okay, see in the unicast you have global unicast address, link local unicast address, loopback address, unspecified address, unique local address and embedded IPv4 address. Okay, this unicast address have so many classifications, right? You know what are all the private address in IPv4? Can anyone tell me what are the private address in IPv4? Yesterday I told
192.
huh? What are all the private addresses in IPv4?
192.
10 dot series,
10,
then
172 and
172.16 dot
192.
series to 31 series, then 192.168.0.02, 192.168.255.255.
Yes.
Okay, those addresses are used in which
Yes, sir.
network?
Private.
Private network. Okay, similarly in IPv6 there is one address called unique local unicast address. What is the address name? Unique local unicast address. Those addresses are used in private network. Where it is used?
Private network.
Okay, so how you can identify that these addresses are private, these addresses are public in private network means the address which begins with the hexadecimal value FC and FD. किस hexadecimal value begin होता है? FC and
D.
FD. All these addresses are called as private network address in IPv6, or another name is unique local unicast address. What is that?
Unique local unicast address.
Unique local unicast address. Okay. Then you have public address in IPv4. Guys.
Yeah.
Similarly, public address in IPv6 also there. That address is called as global unicast address. What is the address in IPv6 for public?
Global unicast address.
So, are you able to see global unicast here written, which is written as 2000 something?
Yeah.
So, the global unicast address range is starting from hexadecimal 2000 to 3FFFF. Any address which begins with 2 or 3 hexadecimal values, those address in IPv6 are termed as what?
Global unicast.
Global unicast.
Very good, global unicast address, and these addresses are also known as public address. What is it called?
Public address.
Public address. Okay. You know one address in IPv4 127.0.0.1. Remember?
Yes.
What is that address purpose? Any idea?
Host.
Sorry?
Local host address.
Local host address. What we will check in that?
NIC is working properly or not.
Very good. NIC is working properly or not. Okay. In the same way, in IPv6, what is the address meant for checking your NIC is, or local host is this one. What is the address? What is the address I typed?
127.
नहीं वो तो IPv4 के
colon
लिए
colon 1.
yeah colon 1. This address is meant for what purpose in IPv6? Same as your 127. Okay, is that clear, guys?
Yes.
Same purpose as 127, checking for NIC. Okay. That is your loopback address. That is which address? Loopback address. In IPv4, you know one address you are using 0.0.0 default routing में. Remember?
Yes.
That in the same way here, the unspecified address is called as like this. If you simply write double colon, then it is called as unspecified address. What is it called? Unspecified address means only double colon will come. Okay. That is an unknown address. Unknown address. Link local they have given. This link local is meant for, you know, ARP process, guys. Guys, you know ARP? ARP पता
Yes.
नहीं है आपको सबको?
Yeah.
SharePoint.
Yes.
SharePoint.
What is ARP?
Yes. Addressing resolution protocol.
What does it do? Very good, address resolution protocol.
IPv4 से MAC address obtain करता है.
Very good. With the help of IPv4 address, we will get the MAC address. Okay. So in that case, there is also one more protocol is there in IPv6. Okay. NDP करके उसका नाम है, Neighbor Discovery Protocol. But I will not go in detail. Okay, that is not there in your syllabus. Neighbor Discovery Protocol. It needs some address help to figure out the MAC address. In that case, that protocol will use one address called link local address. What does it use? Link local address will help you to detect MAC address in IPv6. What is the purpose of linked local address? MAC address find out करने के लिए. Okay, and also if the end devices want to know the gateway, this address will help you to find out the gateway IP. What is the meaning of gateway?
Means the network ID.
The router IP.
Oh yeah,
The router IP is called as default gateway. Okay, and also prefix value /21 /24 like that. Prefix value. Similarly in IPv6 we are using /64. Okay, it will also help you to find the prefix value, the gateway values, okay, the MAC address. Also duplication of addresses in IPv4 किस protocol काम करता है? Duplication of addresses in IPv4. If you and your friend is using same IPv4 address, how your friend machine will come to know that my friend is using the same IP? किस protocol help करता है?
Is it
DHCP.
Sorry?
Is it DHCP?
See here, I will show you in your production network how this packet tracer, sorry, Wireshark you will use. If you are good network engineer, you should know Wireshark. I will show you this. Wait. My cursor is not working. Shit. Okay, now the cursor came. Yes. See here. Wait, guys. Okay, I will right click this interface and I run start capture. Between this router and PC, what are all the traffic is going on, you can see here. Okay, see some this packet will come, brown color packet will come, check it out. See your Ethernet frame, this is layer 1 information. Okay, your clock signal, this is your Ethernet frame. See, destination address, source address, what is the type. Okay, see here, next it will come. See, if I go to this PC and start assigning the same address what I given in the router, at the same address I will use, see it will throw error. I am in the PC now. It will check for duplication of address. See, checking for duplication of address, address is already used by this device. See in the Wireshark, we just stop here, check for GR. It is not, it will show that message, guys. Let me run again. Yeah, let me stop. Are you able to see a coffee color packet here? Or you see GR breakfast, GR reply? Everyone,
Yes.
if I click this GR request, see in Ethernet, this is layer 1 informations, 64 bytes on wire. Okay, and this is your layer 2. See, in layer 2, what is the destination address? What is the destination address?
broadcast.ff command.
Very good, broadcast address. This address is your PC, that PC MAC address. Okay, and what is the type of protocol it is using? 0x806 is which one? ARP. Okay,
Yeah.
so inside the data part you have the ARP is encapsulated inside your Ethernet frame. If I click this ARP, see here, hardware type, protocol type, hardware size, protocol size, it is a request. Sender MAC address is PC MAC address. Hi, my IP address is 1.1. It is broadcasting, and target IPs are also same. If someone is using the same IP address, he is asking. Then GR reply comes. Are you able to see? Previously the target MAC address is not filled up. Now the target MAC address is filled up, guys.
Yes, yes.
So this guy is using this 1.1 like that, he is replying. So duplication is deducted. Okay, so this software name is called as Wireshark. In this Wireshark you can see the IPv4 packets, IPv6 packets, frames, ARP packets, TCP segments, UDP datagrams, and Telnet, SSH, everything you can see. If you understand this Wireshark, then you are a good one of the good network engineer. Okay, so this column will list all the packets, and this column will list in detail. If you select one packet, that packet detail will be explored here. If you select any, if you keep the cursor right here, it will display that data in the hexadecimal format, which is going inside the wire. See? Okay. So what is the software name?
Wireshark.
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 Okay. So that's why I am teaching. When see, for this OSI model itself we are taking this much time. Did you get it? Frame मतलब क्या होता है? What is frame? What is packet? Okay, and what is TCP and UDP we will going to see. Okay, if you understand this, you will come to know how the communication is happening, how the packet flow is working. If any network engineer who is not knowing about the details of frame or Ethernet frame or IPv4 and v6 packets or TCP and UDP datagrams packets, he is not knowing, ARP packets not knowing, he is just simply blankly he is studying networking. Okay, you got it, this one guys? Wireshark.
Yes.
So now coming back to your, so this software name is GNS3 guys. What is the software name? GNS3, graphical
GNS3.
graphical network simulator 3 software. This software is open source. आपका production, you have the production routers, right? Routers and switches. So in that you have the operating system, router operating system, network operating system, switch operating system. That operating system via virtualization we uploaded, and this software is designed. Okay, if you have your own personal laptop, you just install this, but installing this one is not an easy task. You check the YouTube video and install it. If you design any topology, it seems like you are working in the production. It is applicable only for routing and switching. It is not, and also for security 50%. For rest of the wireless, for new technologies and all, it is not applicable. For CCNA it is good. CCNA and CCNP it is good. You can learn a lot. It will give the same output what the production output is giving. Okay. Let me just keep as it is. Let me just stop this devices. Okay, so in the same way, coming back to your IPv6 address, so it will help you to find out the MAC address, it will help you to find out the gateway address, prefix value, then duplication of IPv6 address, with the help of which address they will help you to find all these parameters which I told. What is this address name? Link local address.
Link local.
Okay, I think you won't forget link local. I think you will remember clearly. Okay, so that link local address, how you can identify? It will begins with FE8, FE9, FEA and FEB. I will let you know in the upcoming slides, but I am giving a brief idea. Okay, fine. The last address, this one and this one I will give an idea. Embedded IPv4 address. Combining your v4 and v6 is called as embedded address. What is embedded? Combining your
v6.
v4 and v6. Embedded means clubbing. Okay, and you know multicast transmission, guys, you know multicast.
Yes.
So if any PC is initiating the multicast in IPv6, that will use address called solicited node address. What it will use? Solicited node addresses. Okay, there is one more series is there, that is used for routing, that I will show you in the upcoming slide. Okay, that one and Anycast I will show you in upcoming slide. Now we will see much detail about these addresses. Okay, this is the classification. Now you see, okay, who is the owner of IPv4 address, guys? Who is the owner? Who is it?
IANA.
Very good. IANA. Below IANA, one more guy is there. Who is there? Any idea?
காபிக்கு பால் கிண்ணத்துல ஊத்தி வச்சுட்டு போகுது.
அதை அவங்க கலக்கி வச்சு கொடுத்துட்டு போங்க. நான் எந்த நேரம் எழுந்திரிக்கிறேன்னு தெரியும்.
Okay, see, IANA is giving 16 bits to RIR, Regional Internet Registry. Our India comes under Asia Pacific Network Information Center. Okay, so he is giving to ISP further setting 32 bits. Then ISP is giving to customer like us or companies further 48 bits. Okay, this 48 bits the customer should not change. It is called as global prefix ID. What is it called?
Global prefix ID.
This 48 bits not changed. Okay, then after this 48 bits you have some 16 bits. In general it is called as subnet bits. I will let you know what is that subnet bits. Okay, so preceding this 48 bits there is some 16 bits are there. What is it called? Subnet bits. Okay, then okay, the rest of the 64 bits are called as what bits?
Host.
Host bits
Host
or
bits.
interface bits.
Yes.
Okay, is the name is clear, guys?
Yes.
Global
Yes.
prefix
Yes,
ID,
sir.
subnet bits, interface bits or host bits. Okay, now coming back here, see here global routing prefix, then subnet prefix, subnet ID, then interface ID. Is that clear? Okay, so your global unicast address ranges vary from where to where? Where to where it will
2000
range?
to 3 FFF.
Yes, starting from 2000 to 3FFF. What is that address called in IPv6? Global unicast address or public address in v6. What is that address? Public address in v6. There is no subnetting concept here, so don't worry, but a small concept is there here. Wait. I told you that this 48 bits should not be altered, guys. The first 48 bits.
Should not be altered.
Yeah, the following that 48 bits, you have some 16 bits, right?
Yes.
That is called as subnet bits, I told, right? In that 16 bits, they do some classification. In that 16 bits, what they do, some classification is done. See here, are you able to see red color, orange color and purple color?
Yeah.
Yes.
Okay, for example, uh, you tell me some places in Mumbai. I am not aware of what are the places are there in Mumbai, the area names.
Andheri, Lonavala, Kandivali,
Andheri, Borivali,
Borivali,
Thane,
Kandoli, sorry,
Dharavi,
Dharavi, okay,
Bandra,
Dombivli.
Thane, okay,
Dombivli.
okay,
Ghatkopar.
yes, so many areas are there, right? Okay, so this red color is called as site. Okay, that I will give for Mumbai. That I will give for Mumbai. Subsite is called as whatever the areas which is available in your Mumbai, like you said, Lokanwala, Khandoli, Thane, Andheri, Churchgate. Okay, all these are areas, right? That is called as subsite. In that subsite, suppose for example in Churchgate, I have two networks. That network bits are defined by which bits? Purple color is named as what? Subnet. Okay, so in Thane I will have 4 subnets. In Kandoli I will have 8 subnets. Like that, which bits will responsible for that? Subnet. Okay, site is the main city, subsite is the area, and subnet is your the networks. So if you take, so there are 3 options are given. Option A as how many bits meant for site? How many bits meant for site, guys? For
4
option A,
bits.
2 bits are
2,
2 power 2 is how much?
4.
4,
4. Then how many sites will come in option A? 4
4.
are. Similarly, count the number of zeros and apply the power value and tell me for option B.
16.
16 sites in option B as well as option C.
Yes.
In which option you will find more number of subsites?
Option C.
Option C. In which option you will see more number of subnets?
Option A.
Option A. Okay. See here, after this 48 bits, 49, 50, 51, 52, 53, 54, 55, 56, 7, 8, 9, 10, that is 60, 61, 62, 63, 64. Okay, that's why it is written as /64. Okay, now you see this concept. This is the US map. All the states, US states, if you remember, like Washington, New York, they are labeled with the number. Okay, San Francisco is site number 9, Seattle is site number 9, Omaha is site number 8. Okay, for that site number 0, how many bits they have set? 52.
Yes.
That is for site. That is for which one? Site. Now you just see, if I scroll down, are you able to see for Boston they have given 56?
Yes.
Inside that Omaha or something, in some states, you have some cities called Boston, that is subsite. This 56 is called as subsite addresses. What is it called?
Subsite address.
Subsite. In that subsite you will have number of networks, right? See here. See the subnet address. Are you able to see 64?
Yes. Yes.
So in this way they will assign. You no need to worry about this designing part and all. It will taken care by your network designing team. Okay, you just need to provide, you just see the topology diagram and what is the IP assigned and you provide the support. The people who design this process, which subsite, which site में कौन सा IP address आना है, that people are called as network architect. What they are called? Network architect, their salary will be more than 10 lakhs or 15 lakhs, I think.
Per month.
Okay. Yes. So I hope you clear with this one. Site, subsite and subnet, everyone.
Yeah.
Yes, Santosh.
Check in the chat window, I sent the link. Yes. That is the concept they have explained here, guys, in this diagram. Okay. Now, there is one more address called EUI address. What is this address? EUI address, Extended Unique Identifier Address. Okay. I told you one concept in your MAC address that I informed that I will ask one questions regarding with MAC address. So in IPv6, so remember this part. I told that. Okay. I will ask C. So here they have given one address, IPv4, IPv6 address. See, it is written right. It is visible for you. Is my screen is visible?
it's visible. Yeah, it's visible.
20012342222111
Yeah.
but they didn't give the rest of the 64 bits. If you didn't find the rest of the 64 bits, what you can do is you can take the MAC address of any interface, whatever the address, this address, if you are going to assign for any interface, you take the MAC address of the interface. For example, this is the MAC address given here, 00503E123456. They are in hexadecimal format. They are in which decimal format? Hexadecimal format. How many bits are meant for MAC address? How many bits meant for MAC address?
48.
48 bits. So 64 plus 48 is how much?
$112.
112, right? But IPv6 address is how many bits?
128.
128 bits. Very good. So in order to make a valid 128 bits, I already have 64 bits given in the question, but they are given the MAC address. That MAC addresses I have only 48. I need 16 more bits. What this IANA is saying, you split some rules they are defining. Split the MAC address into 2 off. Divide this. Up to 3 you return in the binary. Then rest of the second half you just write it in the binary. In between these 2 offs, you insert some value called FFFE. What you are inserting? What is the value you are inserting? FFFE. Okay. If you add this 16 bits, this will become 128 bit. Already you have 112 bits. 112 plus 16 is how much?
128.
128. Is the address of the MAC address is same after changing or it is different? This MAC address is changed or different?
Little bit of change.
Changed, right?
Yeah, change.
So there is a bit in your MAC address which notifies that corresponding MAC address is modified. That bit is called as UL bit, universal or local bit. That bit should be inverted. If it is 0, you turn it on. If it is 1, you turn it off. See an arrow mark here given.
Yes.
Okay. So if it is 0, you turn it on, it will be 1. So if you convert this binary value into decimal, 0 is written as it is. What is 0010 in hexadecimal?
2.
2. So it is written as 2. Rest and all will come as same. 50, 3E, FF, FE. You just add this 64 bits to the given value See, I written here. In the given question, I added this MAC address along with FFFE, and it has become a valid IPv6 address. This kind of address is called as EUI64 address or Extended Unique Identifier address. What is it called?
Extended unique identifier address.
So you no need to do this calculation. Router will assign by themselves. See here. If you take this router, I am going inside the interface. See the procedure for assigning IPv6 address. What is the command I am typing? What is the command I am typing?
IPv6 address.
Be louder, guys. Your voice is not audible.
IPv6 address 2000.
Yes. This address is called as public address or private address. This 2000.
Public address.
Public address, right? Now you see, I will assign one more address. It will take more than one address also. Okay. Okay. If you give do show interface F0 by 0 or what is the address I given here? 3000, guys, and I added which keyword? EUI, yeah. And see here 3000, some values are there. Are you able to see?
Yes.
Okay, how this value came, sir? See, I will go do show interface F0 by 0. In routers and switches, you have another name for MAC address is BIA, burned in address. What is the MAC address? Another name? Burned in address. Burnt, BURNT. This is the MAC address of F0 by 0. You split the MAC address into two of CA0113 FFFE F8000 will come. So if you write A in binary is how much?
010.
1010 va? So if you considered the 7th bit, that is 101. 1 is there, you turn it off, 0 will come, right? Then 1000 will come, that is the value of 8. That's why they written here 8. See, and rest of the values are null. They inserted FFFE. Is that clear, guys?
Yes.
Okay, this address is called as which address? What is this address called?
IPv6.
EUI.
EUI. This is IPv6 address, right? But this address has one name. What is that? EUI. Okay, what is the meaning of BIA? Burned in
address.
Very good, burned in address. Okay. Yes, coming back to, yes, I told you link local address, right? Okay, so the link local address beginning value is this one, FE8, FE9, FEA, FEB, starting range of link local address. So it is a system generated address, help to figure out MAC address, gateway prefix, duplication of addresses. Prefix length is your subnet mask. Gateway prefix means router IP. Neighbor discovery in dynamic routing. All this purpose, which address is used? Which address is used for this purpose? Address का नाम क्या है?
Local address.
Link local address. See in this diagram, see here. Are you able to see a link local address here? Guys,
Yes, yes, yes.
it is a
Yeah,
system
we can see.
generated address, okay? It is a system generated address. I told you unspecified address double colon used for default routing and loopback address is double colon 1 to check the functionality of Ethernet card. Okay, there is one address series FF. Any address which begins with FF value, okay, FF01 and FF02. Okay, FF01 is used in if two PCs are communicating, they will use FF01. Okay, if two routers are communicating, they will use FF01 2 double colon 2 for multicast communication. For which communication? Multicast communications. Okay, if you are using RIP, EHRP, DHCP, OSPF and all, they will use this kind of address to send the multicast transmission. FF02 double colon 5, 6 is for OSPF, 9 is for RIP, A is for EHRP, for DHCPs is 2, then 1 colon 2. Okay, this no other option is there, you need to memorize. I am not sure in your Capgemini exam they will ask this, because last 3 exam I am saying there is no question for IPv6 and all, but they are given in the syllabus to eat the brain of the trainer. This one is clear, multicast.
Yes.
Okay. Yes. Unsolicited node address. Unsolicited node address. This is used in your end devices, PC, server, mobile and all, to initiate the multicast transmission. So whatever the MAC address you have, the last bit, right, last 24 bits, it is copied to this FF021. Okay, then it will initiate the multicast transmission. So that kind of address is called as unsolicited node address. So this will initiate multicast from end devices. Okay, the 104 bits will remain same. The last 24 bits is copied from your PC's MAC address. Which MAC address it will copy?
PC's MAC address.
C is match.
PC's MAC address it will copy. Okay. I told you private address in IPv6, right? Private addresses in IPv6. So it will begins with value FC002 and FDFF. All the ranges are belongs to private network in IPv6. Private network in IPv6. Okay. Then what address is left? Yes, embedded address you see. Combining your IPv6 address, then your IPv4 address is embedded address. The embedded address first 80 plus 16 is how much? 96. So 96 bits are 0000 in IPv6. That is your double colon. Rest of the 32 bits are what? IPv4. This address format is called as what address it is called?
Embedded address.
Embedded address. Okay. Yes, last address in your IPv6. You see this diagram, guys?
Yes.
Is all the servers are using same IP address or different IP address?
Same IP address.
Same IP address, right? Your router is receiving a packet to this server. It was not sure that which server am I supposed to send it. Okay. See the cost value 50, 75, 10. Which one is least?
10.
10.
So it will choose the nearest one, that is having the least cost value. That will be the best path, and it will deliver the packet to the server C. So whoever is the nearest address which is having the least cost or metric, that address is called as anycast address. The nearest one is chosen. Okay. Is all the addresses in IPv6 are clear? Guys,
Yes.
next comes your IPv6 is over. The layer 3, one of the protocol IPv6 and IPv4 is done. The last protocol in layer 3 is this one. What is the protocol name?
Internet control message protocol.
ICMP.
Internet protocol.
Any idea what is this protocol is meant for? Any idea according to you?
Error reporting mechanism protocol.
Error reporting mechanism protocol. What error it will report? So you know ping command.
Yes.
Yes.
You guys are pinging, you are getting response. Behind this ping, who is working? Behind this ping, this ICMP is working, guys.
Yes.
Okay, without ICMP you will not get reply and all. So when you ping command, which protocol is coming in picture behind the scenes?
ICMP protocol.
ICMP. Okay, and this is the header of your ICMP, which is written as type, code, checksum and all. And these are all the message types, error code message types. What is 0 is meant for? The message type
Echo
is 0.
reply.
Echo reply.
Reply.
If the type is 8, you are sending echo request. 8 is meant for what? Echo
request.
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 In the morning session when we are doing static routing, have you noticed one message? Destination unreachable in
Yes.
Imran PC.
Yes.
So what is that? Who is giving that error? ICMP only. What is the type number?
3.
3, right? And you see, have you noticed this one? This error?
Yes.
When?
Yes.
When you see in this error?
In
लगता है ना, मगर आपने ये मैसेज देखा है ना कल?
हाँ देखा है.
Yes.
See here, I will show you one more time.
STP, I guess.
See, this error is there coming.
Yes.
So who is generating this error? ICMP only, but the type number is 3. What is the type number? 3. The message name is what message name? Destination unreachable message name, but it has so many codes. So what is the code number? 4. That is the destination unreachable message only. It is giving code number 4 here. See. Is that clear?
Yeah.
So if you have any firewall is blocking port or administratively prohibited, you will get this. If any protocol is not working, this one. If any device does off or any device is not having IP address, host unreachable. 0 is routing problem. Okay, source root failed is your any kind of Destination you apply the routing, but in the source it is not having. So in that case you will get source route failed. Okay, so all
And
this.
destination unreachable means?
So destination unreachable means I am unable to communicate. I am not getting echo reply. That is the destination unreachable message meaning. But what are the reasons you are not able to get the reply means these are all the reasons. Network unreachable, host unreachable, protocol unreachable, port unreachable. This you already know. This one source route failed related to routing issues. Okay. All these messages comes under which one?
Destination unreachable.
Destination.
Okay. And are you able to see here source quench? Source quench is there. What is the type number?
4.
4. If any ICMP packets comes to the router buffer is overflowing. It is not having space for processing your ICMP packets or ping packets. This will generate this message out of buffer. Out of buffer is what is the meaning? Source quench. Source quench means what? Out of buffer for ICMP packets. Okay, last message is redirect. What is the last message? Redirect. See here. Sorry, redirect is there, TTL is there. Wait. Guys, are you able to see this diagram? This one. This R1 and R2 has same subnet but different IP. They belongs to same network. Okay. This PC host edge want to communicate to internet. Okay. But for some reason the link is down. What R1 is doing? So he is unable to communicate with the internet. So he is forwarding the traffic to R2. So he will send a message to host edge ICMP redirect. I am not forwarding your traffic is forwarded to the neighbor router. That is the meaning of your ICMP redirect. Traffic is forwarded to someone. Traffic is forwarded to someone via which message you will be informed to the PC. Via which message?
Redirect.
Very good, redirect message. The last one is time exceeded message. What is the last one? Time exceeded message. I will show you some interesting scenarios here. See here. It's not in your syllabus, but you can see the loop. You know loops. What is the meaning of loops? What is the meaning of loop, guy?
Doing something again and again.
Again and again it's coming, right?
Yeah, repeated processes.
Yes.
Or
So what is the routing I am applying here? Anyone? Do you have idea of what is the routing I am applying here?
routing.
Sorry?
Fault routing.
Default routing. Is the 1.1 is down? Let me check there. Okay, here I didn't assign, that's why. Only I assign IPv6, I didn't assign IPv4, that's why it's not pinging. Am I able to ping, guys?
Yes.
Yes.
Let me close this. See now. If I run the Wireshark again, see if I ping again and see it in the Wireshark, you can see a pink color packets. Are you able to see the pink color packets? ICMP.
Yes. Yes.
If the IPv4 is carrying ICMP traffic, what is the protocol number? Protocol number is how much? How much is the protocol number?
1.
1. Very good. 1. See the ICMP. Type 8 echo request star, and you see type 0 echo reply will come. Are you able to see 0? Okay.
Yes.
Now you see. Now I am going to ping some IP address which is not in the topology. See here. Are you able to see lot of ICMP packets, everyone?
Yes. Yes. Yes.
Yes.
Okay. And see some redirect ICMP is also coming in your case. That will be type 5, right? See what is type 5?
Redirect.
Redirector. And you see here when this packet will keep on roam between the two routers, okay, and it will throw a message called TTL exceeded message. That will be type 11. What is that? Type 11 is called the packet will keep on roam between the routers. When it reaches 255, it will throw an error called TTL exceeded message. TTL exceeded message. Okay, that is one scenario. It will happen in the loop. The another scenario is, fragmentation. Fragmentation, right, guys?
Yes. Yes. Yes.
Yeah, Shankar.
In that fragmentation process, there is some flag called more fragments. So that indicates that the fragment is yet to come. When you receive mf equal to 1 1 means still the fragments are coming. If you receive mf equal to 0 means all the fragments came, it is received by you. That is a notification. Suppose for example I am sending you to 5 fragments, only 4 you have received, last part you didn't receive. The last part, what happens, before reaching to you, it is dropped in between the network itself. In that case, it will also generate a message called TTL exceeded message. Clear? Clear, guys? Okay, your ICMP is over. Okay, so what is the meaning of router? What is the meaning of router? What is the meaning of
I mean
router?
the path to connect to multiple networks.
Okay, path to connect multiple networks. So see here the basic definition of router they have given. Primary responsibility of router. Router determine best path. It will determine which path I am supposed to send the traffic. The best path is determined by whom? Router. And what is the second bullet point they have given?
Forwarding
packets
packets.
toward their
Forwarding packets towards the destination. These two are preliminary functions of the router. Router is a layer 3 device. Which layer? Layer 3 devices. Okay. Your router has CPU, flash memory, which has iOS content. Okay. Routers are like computers. Okay. So you know running configuration file. What is the command to check running configuration file? You forgot the command. How many times you executed? Show run, you know?
Show run.
Yes. And what is the command to check routing table?
So MAC address, show routing table.
Show MAC address.
That's what MAC address.
Show IP route. Routing table means show IP route. MAC table means which one?
MAC address table.
Show MAC address table. And you can check ARP also. See here. Do show ARP. Do show ARP. Okay. ARP cache we will see that table. Okay. Then your packet buffer, where your packets are processed in that memory. For all this process, who is providing memory? Which memory is used?
Cache memory.
Sorry?
Memory.
Guys, your voice is not audible.
Flash memory.
Flash memory. See the heading RAM.
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 RAM is used. Okay. Flash is used for storing your operating system of the router or switches. किस मेमोरी में iOS स्टोर होता है? फ्लैश मेमोरी में. जो मैंने ये पॉइंट बताया था, रनिंग कॉन्फ़िगरेशन फाइल, IP routing table, ARP cache, packet buffer, everything needs which memory?
RAM.
RAM. Okay. What about NVRAM? What is NVRAM? What is the command to check NVRAM? What is the command to check NVRAM? Show startup config. Remember?
Yes.
In that only you will check NVRAM, right? Files. So in show startup config, in order to display the show startup config, what is the command we frequently run in CLI? A command है जो frequently run करते हैं. What is that command? You know do WR?
Yes, yes.
What is the meaning of write command?
You store the
To store from which memory to which memory?
When we run.
RAM to NVRAM.
Very good. RAM to NVRAM. Okay. So in that NVRAM you will have the running configuration file saved permanently. Okay, it will retain that file. See what is read only memory, what are all the process it will do means, see I will explain in this booting process of the router, what this ROM will do. This is your internal part of the router. I will explain what is our read-only memory functionality. And this is your CPU. This is your RAM. Power supply, fan is there. Flash. I think I already shared this slide to you in the drive link, right guys? Monday I shared. Anyone who didn't get this slide deck? Okay. How a router boots up? Have you know power on self test, guys? Have you know power on self test?
Yes.
What does it do?
Internal hardware.
Very good. It will check for the internal hardware is working or not. Okay. So initially when your router or switch is booting, your ROM will do this functionality. Power on self test. Is the all the hardware is working fine or faulty or not? Even in your Windows, if you boot up the PC, the BIOS will check for the internal hardware diagnosis. Okay. If there is any cable, SATA cable is plugged out from your hard disk, it will display that cable is plugged out, SATA cable. And if you, what is blue screen of death in your Windows, guys?
System crash.
System crash, or if your RAM is corrupted or CPU is overloaded. Okay. And if you have any error in your CPU processing, you will get this blue screen of death error, BSOD error. Okay. So in the same way, it will check for this power on self test process in your router. If this successfully passed, this ROM has read-only memory, has a software called Bootstrap program. Like you have bootloader. What is a bootloader used in Windows? You completed Windows and Linux session. What is the bootloader you are using?
BIOS.
NT loader, right? NT loader something is there. That is the bootloader used in Windows to locate your Windows operating system. Where your Windows operating system is located?
Hard disk.
C drive.
Okay, C drive in which location?
In the Windows folder under C drive.
No, there is something called master boot record, you know.
Yes.
In that only it will try to
Yes.
locate it. Okay. What is sectors in drives? What is sector in drives? How many sectors are there? Based upon that only it will try to store the memories and all. You studied this in Windows, right? What is the loader used in Linux? Have you heard of grub loader? GRUB.
Yes.
So that is the
Yes.
loader used in
Lilo
Linux.
also is used. No?
Yes, nowadays Windows is also using that one. Okay. And similarly here we are having Bootstrap code, which will load your operating system from flash to RAM. It will deliver. It will locate your operating system. What is the purpose of this Bootstrap? It will locate your operating system. Where your operating system is located? Flash memory, yeah? In your routers and switches. Okay. So after finding out it is located in the flash, this flash will start booting. So like that you can see in your packet tracer, you can see self decompressing will happen. See here. Are you able to see self decompressing the image? This means the OS is booting. Okay. After finding out the OS is located, the OS will the after shutting down the router, the image will be compressed, so it will decompress the image. That's why it is saying decompressing the image, okay, from the flash memory, and it will deliver to your RAM. That's why it is showing this hash symbol, hashtag symbol. Then after that, it will check for any configuration files residing in your NVRAM or not. Residing in which memory? NVRAM or not. If it is there, it will directly come to your user mode. If it is not there, it will prompt for setup mode. It will prompt for which mode? Setup mode. So in this way only your router is booting. This way only what is booting? Router is booting. Okay. In some cases, if your router is not booting, you can download the iOS image from the server. That's why they are given here TFTP server. Okay, in case your router is booting successfully but configuration file is not there, it is residing in server, you can download from the server. That's why they are given TFTP. Okay, so everybody clear with the booting process of router? Guys,
Yes.
to know more about the router models and all, you check the vendor's website. Okay, like we seen switches, right? The number of ports and all. Remember Cisco Catalyst switches. The same way you visit the vendor site and check for how many ports are there. See, you can see the console port, auxiliary port. See, this is the rear part of your router, back side. CL port is there, console port is there, LAN port is there. This is the empty slots where you can put new interface in the slots, and power on button is there, LED buttons. Okay, so depending upon the router's criteria and model and customer requirement, it may vary. Okay, the new device launched by Cisco in this 2015 and all, it is called as DNA hardware. It is hardware as well as software is there. Digital network appliance. Okay, what it will do, suppose you have whole Capgemini network of India. Okay, you have all the routers and switches, servers and all these routers, switches, wireless devices, you can monitor in a single window, and you can configure also. Even you can locate the devices in that window, in which location and what is the latitude, longitude, and how you can sit. Suppose this DNA is installed in your Delhi. From Delhi, sitting in Delhi, you can install Chennai, Bangalore, Kochi, Hyderabad, Mumbai, Kolkata, any places. And if there is something faulty, it will prompt you immediately. So no need to go to the, suppose the people who are sitting at Chennai, they need to have the connectivity. That's it. Their devices configurations will be empty, but everything will be uploaded from the Delhi itself. At a time you can upload more than 1000 devices at one time. At one time you can upload how many configuration files for any devices? 1500 devices you can upload. That is your speciality of DNA. Okay, so that devices details and all, you can check it in Cisco website. Okay, and you know, already know this command, I think, this one and all. See, you know configure terminal enable and all.
Yes.
You know host name, you know password, console, telnet password, console password, secret password, banner.
Yes.
Okay, see, they are given. So this completes your layer 3. Now we are moving to which layer? Transport layer. We are moving to which layer? Transport
Transport layer.
layer. Okay, so I will stop the recording.